Hello, it's a pleasure to talk here. Thanks for being here. I'll talk about two projects, my nighttime project being Encointer, my daytime project with my company Supercomputing Systems, which is SubstraTEE. So at first, Encointer, the nighttime idealistic project, is about implementing a global basic income. Now, the whole economy of it, as this is a developer conference, I won't cover. So it's more about like the technicalities of it. So I have the following assumptions. We want to have an unpermissioned blockchain, and we don't want to require any state-issued IDs. Only self-sovereign IDs. And now, if we are to give a basic income, we want to be sure that we give this income to humans only, and we also want to be sure that every human gets that income only once. Now, that is not very simple to solve. I came up with a process which is a little, takes a little effort from the participants. The idea is that all the participants who want to receive this basic income, they have to participate in meetups which happen all at the same time within a time zone all over the world in randomized meetup groups. And the idea is the following: you can only be in one place at one time. So if all these meetups happen at the same time in different places, you can only attend one of these meetups. So how does this look like? Before that key date, these ceremonies, they happen every 41 days. That's just an arbitrary number, but it shouldn't be too often because it will be cumbersome. So a little bit in advance, you register on-chain where, well, more or less where you are and how far you are willing to travel for the next meetup. So Alice, Bob, and Ferdy, they have their kind of tolerance region, and the intersection now is where they will meet, where they will have their meetup. And an algorithm will make sure that it's, well, first randomized, and that that the meetups don't happen like at a very close distance. Now, what we get with these meetups is not only a one-to-one ID. So, I mean, that's the first thing. Every human can get exactly one ID. But because we have these meetups, we actually have a proof of location as well. And that means that this basic income, which is actually delivered as money issuance, so we issue fresh cryptocurrency on behalf of the participants. So it's an inflationary model, but this basic income is actually tagged to the region where you participated. That means we can have local cryptocurrencies, and as far as I know, that's a novelty. And local currencies also means that they don't necessarily need to have the same exchange rate, of course. So on the right side, you see the now the more technical slide. You see what the first proof of concept can do. There is an Android app that allows you to register for the Encounter ceremonies, and then you meet people, with Android nearby. You discover the other participants, and you can just sign their claims. And then send all the claims to the blockchain. And the blockchain is substrate-based. You register participants, the blockchain assigns the meetups, the blockchain verifies the meetups and issues fresh money as basic income. And the app is a Java app, Android app only right now. And the clue for rapid development was just to have a native Rust library which covers all the substrate specific stuff, so all the crypto primitives, extrinsics, and so on. And so we're using the Substrate API client, which is a Rust client, to talk with the RPC interface of a Substrate node. And yeah, more info is on Encointer. Now, a very important thing, especially for Encointer, is privacy. Because if you commit to be in a certain place at a certain time, that means, for example, if you are identifiable, that probably no celebrities will take place, will participate, because it's really dangerous for celebrities to commit to being in a certain place. With just random people, I guess. But also the transfer of money should be all private. And that's what brings us to the Daytime project, to the Web3 grant project, SubstraTEE. That's with my team at Supercomputing Systems. We're doing this, and that's about trusted computing on Substrate blockchains. What we claim with this is a bit steep. we say we solved the three big challenges of blockchains today, which are confidentiality, how can we comply with GDPR, scalability, and interoperability. So SubstraTEE is actually that technology. We use trusted execution environments for that, and that comes, of course, with a trade-off, because trusted execution environments require us to trust the manufacturer of that hardware. A first demo, which is a private token transaction, which I will explain later, can be found on GitHub, so it's all in Docker and very easy to try out, even if you don't have any T hardware at your disposal. So what's a T in the first place? We are very used to the fact that whoever has administrator privileges on a machine can do whatever he or she wants with that machine. And not only the administrator, but also all the malware which can get administrator privileges by some way. And the trusted execution environments are actually isolating a process completely from the operating system and the access through the administrator. So the admin cannot see the memory of the process, it cannot change the code of that process. And so the same applies to malware as well. Now, how do we apply this technology? We want to interface with any Substrate blockchains. So what we do is actually just a building block. It's more of a tool. We're not having a chain with a token and stuff. So that's for all of you to use. Where we register our trusted execution environment on chain, and from then on, people who interact with this can have confidentiality. You can instantiate runtime modules, paint palette modules, whatever. Not on chain, not in the runtime. You can instantiate exactly the same code that you wrote for Substrate in our off-chain worker. And I hope soon this will be possible for ink contracts as well. Now, why should we trust this off-chain worker? We have open source code running in this enclave, but I mean, who would believe me if I say that's exactly the code that I'm running on my server? So what we need is remote attestation by the manufacturer. And how this works is the code that is run on the T, the T can be challenged by the manufacturer in such a way that the manufacturer can attest to the users that A, it's a genuine hardware, and B, that the code which is running on that hardware the binary has the hash XYZ. So if you can build the source code deterministically, you can actually be sure you can compare the hashes of the remote attestation and your build. And this remote attestation is actually sent to the chain. The chain can verify that this attestation and will only accept workers with correct attestations. Right now we use it with indirect invocation, so the substrate chain is not only a register for workers, it's also a proxy for requests. And how this works is, let's say Alice wants to send tokens to Bob, private tokens, which are managed in a state in our world. So bear in mind, the state of the chain has nothing to do with the state in our trusted world. They're completely isolated. So Alice encrypts her call with the enclave's shielding key, such that when the extrinsic hits the blockchain, which is public, the actual payload is opaque, so no one sees what's in there. So then this is forwarded by means of an event. So we listen just over on the RPC interface, we listen to events, and we forward, we decrypt the request. We send it to the state transition function, and in the case of this demo, the state transition function is nothing more than just the balances module from Substrate. And then you can have your transfer, whatever. This works on a state which is encrypted, and the encryption key of that state is shared among a redundant set of workers. And the state is shared over IPFS. And the next thing that we want to do, so that's not yet implemented, is trustless chain state read. So as I said before, the state is completely isolated, but some use cases require that we can read on-chain state, and that's what we would like to do. So actually what we're doing is we take the Substrate Lite client, we put it in our enclave, and it will be able to verify proofs, read proofs, and kind of proof of inclusion, and so on. And now, so far we were talking about confidentiality, but scalability is the next goal, a bit further away. So we can use SubstraTEE actually as a second layer protocol. We can, as a requester, talk directly to the off-chain workers and not have on-chain transactions for every request that we have. So we could process thousands of transactions and only write the Merkle root to the blockchain as a confirmation that all these requests have been processed. Okay, so where are we now? We have up to M4 was the grant with Web 3. M5 is what we continued on our own with, and M6 is kind of the next thing that we want to do, which is the light client functionality. All right, that was it. If you have any questions, please, if we have time.
I have maybe one question. I didn't understand how you want to make sure that if I attend one time one meeting, that the same person do not attend next time a different meeting.
Okay. Actually, I don't care which persons or who actually attends with what ID, because I just care about it being a human. And if you want to have a consistent one-to-one ID, then you have to link just your participations of maybe the last 5 ceremonies. And if you have attended more than half of the ceremonies, then you kind of prove that you only maintain one ID. Because if you attend 50% of the ceremonies, then it could be that you actually attend 100%, but like you alternate two identities at the different occasions, which would actually give you 2 IDs. So this kind of allows us to have a trust rating on the ID. If you have the majority of the attendance, then you can be sure that this person only maintains 1 ID.
My question is a bit off topic. You mentioned Substrate API client, and I'm curious, how would you compare it with SubXT? SubXT is a bit changed last time.
I'm aware of SubXT, but we were not aware at the time because it was written more or less at the same time. How I would compare it is our Substrate API client is it's synchronous, and it allows you to compose extrinsics even in no standard environments. So that was important for us to use it with SGX, because SGX is also a no standard environment, and we needed to compose and sign the extrinsic within the enclave, because that's where the private key resides. Does that, I mean...
Yeah, that's useful. And does it up to date with Substrate 2.0?
It does work with, well, let me see. I think it works with a commit which is 1 or 2 weeks old. So we do not stay up to date the whole time. We kind of, and I mean, this might be a recommendation for some of you. As this is really a moving target, it really makes sense to like commit, pick one commit, work with this, and update only if you have any problem with the state that you're working with.
Well, 2 weeks ago is okay.
It's not exactly continuous integration at its purest, but it saved us some work.
Yes, thanks.
Any other questions?
I'm actually, with Encointer, I'm kind of hiring, but I'm not paying. So it's a not-for-profit project. So approach me if you want to do like altruistic work.
Awesome. Thank you so much, Alain.